today we're going to talk about factoring beyond quadratics. So what I mean by this, we've been focusing on ax squared plus bx plus c, right? And when we set that equal to y, it forms a parabola, right? This sort of a graph. Now when we factor, we haven't really gone over this, but what we're finding when we factor something like this is we're finding the points where y is 0, which are the places where it crosses the x-axis. Now, when we start to get a little bit more complicated, so what if we had y equals something like x cubed plus x squared plus x plus some constant? Factoring something like this is really a lot more difficult than what we've been doing. But it can still be important. And so what I'm going to show you today is a trick that will sometimes let you factor things that are bigger than just x squared. And it only sometimes works. So let's say you had a problem like this. X to the 4th plus 2x squared plus 1. So what I want you to notice about this is we still have 3 terms, right? This is still a trinomial. And this trick will only work if you have a trinomial. Well, it's only sort of true, but for now, let's just say it will only work if you have these 3 terms. The other thing that you need to notice is that this, the lead term, is this squared. Okay? So the first term is the second term squared. Without the coefficients, right? So ignoring our coefficients. And when you see something like this, you actually can factor it using what you already know. And this is actually the easiest way to factor something. So what you would do here is you would say, I'm going to make y equal to whatever my b term is. So whatever my second term is. In this case, I'm going to say y equals x squared. And then I'm going to rewrite my expression using y. So to rewrite this using y, x to the 4th is x squared squared. And x squared is just y. So this is y squared. 2x squared is going to be 2y. And then my last term doesn't really change. It's just 1. Now, this looks like something that you know how to factor. So now we can factor this. We would have y plus 1 and y plus 1. And then the last step is just rewrite again. Getting rid of y. So we would have x squared plus 1 and x squared plus 1. Because that's what we said y was, right? Y is x squared. And then we're done. We factored it. So you just factored something with a 4th degree in it, which is pretty cool. That's pretty advanced, actually, to be able to factor a 4th degree. Now, you can't factor everything with a 4th degree.
And we did that because y equals x squared, right?
Yeah. So I rewrote this just using this trick of y equals x squared, turning this into, this is now a quadratic, right? This is a parabola, or a quadratic trinomial. Whereas this one's not, so we don't really exactly know how to factor it in this one. But when it's like that, it's pretty simple to factor. So let's try that again. Let's do another one. What if I had something like this? This one's going to be a little weird, but x plus 3x to the 1/2 plus 2. So again, this is weird. This doesn't look like something that we've been factoring. It has an x. It has no x squared. But we're going to set y equal to x to the 1/2. Because that's our second term here. So y equals that. Then what is y squared going to be?
X.
Just x. Perfect. That's what we have here. So now when we rewrite this, x is actually y squared plus 3, x to the 1/2 is y plus 2. And now that looks a lot more like something that you guys know how to factor. Something that you could factor. Right? We would factor that just by saying maybe y plus 1 and y plus 2. But our equation, our original expression, has no y's. So now we want to rewrite that instead of y using x, remembering that y is x to the 1/2. And so this would be x to the 1/2 plus 1 times x to the 1/2 plus 2. And then you're done. You factored this weird thing. X to the 1/2, remember, is the same thing as the square root of x. So you've just factored a square rooted expression, which is kind of cool. Kind of different. Just adds another little dimension to this.
How would you graph that?
Yeah, so actually graphing these would be a little bit more tricky. But you have some place to start, right? You have you'd have to figure out what would make this into 0, right? Which wouldn't actually be that hard in this case. Because we know the square root of 1 is going to be 1, but then there's nothing that's going to be the square root that's going to equal a negative number. So we're not going to go that far, is the answer. That gets a little bit too tricky. All right.